Continue from our previous lecture, we talked about the residual plot. Let's see one more example, then we will have some summary. Okay, so we continue to see one more example. So this example is about the US woman. So if you run this table, you will find actually we have 2 columns, and also we only have total 16 data. So that's the US woman height from 58 inch to 72 inch. But you can see they only have one weight. So on the other hand, you see this one, the weight is what? It's average weight. So that means we already in this table, we make our 2 columns, one is height, but the other height is the average height. So for women, all are 58 inch. The average weight is this. So then 60 inches, they are 120 pounds. Okay, so then you will see what the scatter plot will look like. Okay, yeah, they are kind of exactly the straight line. Okay, and if we try to see the correlation, their correlation is 99%, 0.99. Then if we plot the residual, okay, so then we can see, yeah, the line actually is fit pretty well. But residual actually is what? Supposedly the line look very good, right? It's very fit. But then you can see this residual is what? Yeah, again, you can see the residual, we have the 0 here. So then we can see the range actually is very small. So then for the height under 61, they are positive residual. And over 70, they are positive residual. So then in between, they are negative residual. So what did you find? So actually, this one actually, even you feel like they look like very fit for the line, right? But this data already doesn't have this variety because we already find using the average. We just have all the height together, then we find the average weight. So that's why we cannot see the distribution for the women live in different neighborhood, what their height will be. So instead, we just find all the same height women, we find only using one number to represent their height. Represent their weight. So then you can see the residual look like this. So our residual plot look like this. What does that mean? Okay, so actually, that's we give you the summary for now. Okay, so why we need a residual plot? We make the residual plot. What's that for? The residual plot actually is the scatter diagram of the residuals. That's you see we make all the dots for all the residual. Each residual is the observed y minus your estimate y. So your scatter diagram should look like an unassociated blob for linear relations. So they will show pattern for nonlinear relations. So the most important thing, why we have the residual plot, we use that to check whether linear regression is appropriate to represent our observed data. So that's why here, if they are a good representation, right? So your residual, right, they still have the average is 0. They may have positive, they have negative. But supposedly from all those scattered plots, we shouldn't find any association on that. So that's why we say they should look like an unassociated blob. Okay, so maybe they will show pattern, but it's nonlinear relations. So if in your residual plot, we find some change in spread, outlier, or any other pattern of curves or a trend, okay, so if we have that, that means your observed data, even they kind of have regression line, they maybe have good correlation, but they are not a good fit using the regression line. Okay, so we back to see our plot earlier. Okay, so that's why you see from beginning, we show you, we used our we're using our demographic data, right? Okay, so that's why you can see here. Okay, so then you can see our residual plot. Yeah, even like we say, they have the 0 here, they have positive, they have negative. But did you see any association? Yeah, we just see they have a lot there, they have a lot here. But they don't have like specific region. Some most are positive or most are negative. So the same thing, we see the parents' height example. Okay, so then you can see again the residual, the same thing. Okay, we didn't see the pattern at all. Okay, so they do have the 0 here. Okay, but in all the region, they do have some positive, they do have some negative residual. Okay, so this too is a good example. The regression line is fit pretty well for our observed data. But when we talk about our Dugam example, okay, so from here you see even we really make a straight line for that. Okay, so then from we observe our residual, then we do find some pattern. The pattern is what? When they're under 2.0, they are positive residual. So then between 2 to 2.6, they are most are negative residual. So then they're back to the positive residual. So on the other hand, the linear line maybe not a best fit for our data. So on the other hand, we go back to see again our observed data. So you can see maybe they do have some curve, right? So maybe they have better way to fit with that, maybe quadratic equation or something else. So then we see the UX woman height. Even we see here, yeah, they do look very good, right? So that's our regression line, that's our observed data, and the correlation is 0.99. Okay, even they look so great. But when we see the regression line, okay, so then you can see they do have some pattern here. So on the other hand, this one maybe we say they are not a good fit for the regression. The regression line maybe not a good fit for the data. And also we go to see the data itself again. Okay, so here we just use one weight, average weight, to represent a specific height for the woman. Okay, actually it's not a good represent weight for the height of woman, right? So they have so many variation in there. So but since we average that, we already ignore those variation. Okay, so that's our residual plot. So from the residual plot, it can help us to go back to see the regression line is a good fit or not for our observed data. But continue to talk about residual. So we want to give you some properties about the residual. So residuals from a linear regression, since here is linear regression, always have this following property. The first thing, 0 mean, just like our standard deviation. Okay, so then since we have positive residual, we have negative residual, but they should even out. So then they will have the 0 mean. So that's why your the root mean square error will equal to your standard deviation of the residual. And they don't have any correlation with x. And they don't have any correlation with the fitted value. So the fitted value actually is the y we have from our regression line. Okay. So then these are all true no matter what the data look like. So that's why as long as your data has a good fit for the regression line, the residual have that property. So why the residual mean is 0, just like the deviation from mean are 0 on average. Okay, so we will go back to see here. Okay. Yeah, sorry, my recording tool has some issue. That's why I back and forth for some windows. But anyway, like earlier we said, our residual average always 0. So that's why here we told you no matter what, okay, no matter what your data is, the residual average is 0. So that's why here we just do some calculation. So this one is our Dugan data. Okay, so we got our residual. Okay, so then we just using our NumPy average to run. Okay, so then you will see, yeah, that's 0. So then you plug in your the parents' height with the children height. Okay, so then we find out, yeah, you're passing through their residual, right? So their average still 0. Okay, so that's our demographics example. Yeah, still 0. And remember we told you, right? Your residual also has no correlation with your x and no correlation with your fitted value. So that's your estimate y. So that's why we just using this example is our height example. So we have our parents' height and children's height. We just find our residual and our fitted value. Okay, so then if you're using the fitted value and the residual or the meet parents' height, so this one actually we're using the meet parents' height. So average for the parents' height, that's x. So then we see with the residual, do they have correlation? Yeah, their correlation is 0. Okay, so the same thing. Yeah, your fitted value with your residual in the parents' height, they are 0. Okay. So continue like earlier we say, the residual, no matter what your data is, how your data look like, the residual property, we have 3 property. They do have all the average for the residual should be 0. So then our residual has no correlation with the x and also no correlation with the fitted value. So earlier we see the example for the height. Okay, so then how about we just check the Dugan data as well. Okay, so the same thing. So we add our residual and the fitted value into our Dugan table. Okay, so we check on the Dugan length, that's x with the residual. So that will be 0. So then we're using the fitted values and the residual. Okay, so that's the y, your y and your estimate y with the residual. So that's 0 as well. Okay, so we go back to see our lecture. So that's we show you the residual for the linear regression, they always have a 0 mean. They have 0 correlation with x, they have 0 correlation with fitted value. But earlier when we say you see from the residual plot, if we find some pattern, we need to go back to see maybe the they have some pattern, so that's mean the residual line maybe is not the best fit for that. But they are not affect your residual has these 3 properties. So these are all true no matter what the data look like. So that's our residual. So we still have a couple minutes. So one thing I want to go through with you is the discussion question. Okay. So then here we talk about, because like earlier we said, you have the 3 residual property. So if you have your regression line facing that situation, okay, so what we should do? So the first one, if your average residual were 10, if the residual were positive correlated with the x, so or your residual were above 0 in the middle and below 0 on the left or right, so what should we do? Yeah, pause the video to think about that or discuss with your classmates. So then I will show you the answer. Okay, the first one is the average of residual was 10. So what should we do? So this one actually we need to move down. So since your average of residuals should be 0, but they become 10, what does that mean? So that means all the residual actually they are 10 more. So that's here we need to adjust our intercept for our regression line. Okay, why? Actually, you can go back to see here the regression definition. Okay, the regression definition is observe y minus your regression estimate of y. Okay, so that's why you see here, this one, observe y don't change, right? So then you become positive 10. So that means here you are y kind of smaller a little bit. So you just need to shift your y for 10. So how to shift? Y actually equal to mx plus b or ax plus b, right? So your ax, your slope and x don't change. So then actually is your b need to change. So we need to adjust your intercept. Okay, so the same thing for the second one. Okay, if the residual is positively correlated to the x, so that's your y equal to mx plus b. So this ax has issue. So that's why we need to adjust our slope. Okay, so then the last one, if the residual were above 0 in the middle and below 0 on the left and the right. So this one kind of is opposite for our Dugan question. Yeah, our Dugan question is they actually in the middle, they are below 0, but they left and right, they are positive. So on the other hand, this one just means the regression line may be not the best fit for our data. Okay, so that's our discussion question. Make sure you understand why the answer is and discuss with your classmate. So then that will help more, or join the office hour. So here is our lecture 32.